Okay, so in this video, I'm going to show you how to make an improved audio signal switch. Last time we used a CD4066 chip. This time we'll use a CD4052, which actually seems to be designed specifically for what we're trying to do here. So this chip is basically it functions in this case as a 4-to-2 multiplexer, or demultiplexer rather. It's a 4-pole double throw switch. So you can put in a left and a right channel and switch it to one of 4 channels. So you can have 4, and it goes both ways. So you can have 4 sources and just pick one of them and channel it to the output. What selects the source is basically a 2-bit input. So it's like 0 or 1 on each input, and that selects in binary which input. So the main advantage of this chip, though, is that it's designed for dual supply operation, which, I mean, I guess you can't really do with the 4066. You can kind of improvise, but with single supply operation, you basically bias the circuit at about half the power supply voltage, so that the signal, represented by the sine wave, rides between the power rails, so that the whole thing can be amplified without clipping. The MOSFETs in there that are carrying the signal, the drain must always be greater than or equal to ground for it to conduct properly. If it tries to go to if the signal is, like if the drain voltage is less than ground, the MOSFET will just clip the signal. It won't actually function properly. And so, like in the last video, we had a potential divider putting half the supply voltage on the drain, so that the drain is now biased half the supply voltage above ground. And for dual supply operation, there is no bias, so the signal swings equally above and below 0 volts. And as long as the drain voltage is greater than the source voltage, we're good. And this makes everything a whole lot simpler. You don't have to have capacitors on the input and output to isolate the DC bias from the rest of the circuit. So that makes this chip a whole lot better suited to something like this, where you need to switch like audio signals. And plus you can do 2 more sources with one chip, so that's really good. Now I'll show you how you can switch just 2 sources or all 4 using a couple of fancy 555 timer circuits. So right here you've got basically a bistable latch with a 555. It's probably one of the most basic circuits you can make with it. Basically what you have is a normally open push button switch that grounds out a capacitor that is charged on the output. So if the output is stuck open or stuck closed, like high or low, the capacitor will reflect that. The capacitor is actually there for debouncing, so it's like you have to hold the switch for a certain amount of time for it to actually switch the output. So if you just like, if there's noise or something, it won't false trigger it. But basically the output will hold on or hold off if you press that push button switch. It only requires 1 push button switch. If you remember in the CD4066 video, it needed 2 switches. And that's for 2 inputs because it's just 2 states. And then the other, you tie this to like perhaps the A input there, and then the B input would just be tied to ground or to power, which would select either these 2 sources or these 2 sources. So then you can, for 4 different inputs, you'd have to make, I guess there's multiple ways you can do this, but the way I chose to do it was to make a 2-bit counter, which is basically a 555 timer in monostable mode. So when you press the switch, it just sends a pulse, and that pulse feeds a CD4013 chip, which is basically a pair of D flip-flops, and they're operated as bistable latches, basically. So there's the clock input there, and then the output's like fed back, and the outputs hold the 2 bits of interest, and we tie both those to the A and the B input, and then voila, we have a switch that when you click it 4 different times, it goes through 4 different states and selects the 4 different inputs. So here's a more detailed circuit diagram of the CD4052 chip. And basically you have your source and then all the pin numbers, so you can try and build this yourself if you want to. And there's one issue with this chip, however, and that is it is only rated for 20 volts total between the power pin and basically the full voltage can't be greater than 20 volts. And so I'm running this on +9 and -9 volt power supplies. And that's less than your typical ±12 or ±15 you'd get with like a typical op-amp circuit. So you have to watch out for that. You'll have less headroom with this type of switch. There's also an inhibit pin, pin 6, and so you can actually just shut everything off, shut the outputs off completely if you want. Yeah, and so you use either the 2-bit counter to select all 4, or you have a bistable latch, which will just select 2, but then you tie the B pin to 9 volts or to ground to select either pair of sources. So it's actually pretty simple. In fact, in many ways, it's a lot simpler than the 4066 chip, because you don't have to bias it. So here's the circuit. Here's the 4052, and here's the 555 timer bistable latch thing. I've got plus and minus 9 volt power supplies powering this thing. The chip can only take 20 volts maximum between supplies, so I figured 9 volts is probably apropos. So I'll play some music through it. If I press the button, it goes away. I got nothing on this other channel here. As you can see, it works perfectly fine. There's no feed through, and it's in stereo. This is just for the 2-channel version, where you have only 2 channels hooked up, and a bistable latch is connected to one of the binary pins, and the other is just simply tied to ground. That's just for the first 2 sources. If you wanted the last 2 sources, you could obviously tie B high, and then you have access to these lower 2. Another thing I ought to point out, though, is this pin 5, this control voltage pin, you don't actually need to put anything on it. It's just that it's just not good practice to leave a pin floating on a chip. So it's usually tied to ground with a capacitor. You'll see on the breadboard, I don't actually have it there. You don't always need it. Sometimes if the chip whacks out and it does weird stuff, you might put it in and it might fix the problem. But it's not essential. So if you don't see me add that capacitor, it's not essential. All right, so this is the 4-channel selector of this pretty much the same circuit. I got a couple of LEDs here to indicate the state that it's in, because I don't actually have 4 different sources. So I've got a 555 timer, a switch, which moves it through the different states. You have 0, 0, 1, 0, 0, 1, and 1, 1. So 4 different states this chip can be in. And this is basically just a 2-bit counter. It's a 555 acting as a switch debouncer to give a steady pulse to the CD4013 D flip-flop configured as a 2-bit counter. Very, very simple device. I also grounded, not shown in the schematic, I grounded the set and reset pins. I guess it's good practice not to have flying leads, especially on CMOS digital chips. So I'll show you what this thing does. I have to take the LEDs out because this chip can't actually drive the LED current. It'll pull down the voltage too much. So I'll do this. So you hear music now. Nothing, nothing, nothing. 2, 3, 4. Sometimes the switch. Anyway, you get the idea. You can switch through 4 different sources with this thing. It's easier than trying to finagle a 4066 CD4066 chip to work in a similar situation, this chip is more designed for exactly this purpose.